Good morning, folks. So, yeah, another day, another dollar, as they say. So, yeah, Friday, weekend. So after work, won't be going straight home. Definitely gonna go and mooch around somewhere, probably in central London. May even head to Wembley yet. I don't know if I'm going to do that today or tomorrow. Actually, I'm not sure. Maybe leave it until tomorrow, because then I can get an early start and have longer for for the day. But I'm still a bit undecided. But it's either tomorrow or today. I'm going to head to Wembley. Got a bit of wind here. That's the thing, you see. That's the other thing about this time of the year, is trying to avoid wind and stuff and what have you. And of course, the quality of the light at times can be also bad. Just lately, I've been having to, you guys may have not noticed, or maybe you did, but at times when I've been walking along doing my vlogs and stuff, especially with the early morning, the light at times, my face is quite in dark and quite in shadow sort of thing at times, even just walking in a normal street. It's not like I'm like in a dark place or something, do you know what I mean? It's just because it's early morning and the light quality. So I've had to lighten it up. So in certain sections of the video, you may or may have not noticed, I've actually brightened up the light and brought down the contrast so it doesn't look too the same as well. Anyway, blah 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 blah. So yeah, so that's what hopefully either later on we're going to go to Wembley, or today, so I think, or tomorrow definitely, because that's Sandra's old stomping ground. When Sandra lived here for a little while. That's where Sandra lived, around Wembley area, around there somewhere. Not entirely sure exactly where it is. I'm trying to find this recreation place that she was talking about as well, sort of like green area, countryside-y thing, whatever. Anyway, blah blah blah. So yeah, now the thing is, this morning I wanted to talk about a really interesting subject. I'm just thinking, actually, instead of, I'm going to stick the camera over here, just as long as there isn't too much wind noise, of course, because I'm thinking, rather than me hold it, because actually I find it easier to talk when I've got my hands free, because I talk with my hands, of course. I don't know if you guys have ever noticed this, but I tend to talk with my hands. You probably haven't really noticed it that much, because the thing is that, right, sorry, give me a second, folks. Technical issues with the tripod. Right. Okay. So, actually, wait. Sorry, folks. Trying to. Right. So, basically, and I'm thinking, actually, I might leave this for, well, not leave it, but I mean, I'll touch on the subject now. But this might be a subject for the Monday live stream. So, as you guys now hopefully have become aware, that I do a live stream every Monday at 6 PM. And yeah, so I must write this down. I'm starting to make notes of stuff as well. I'm putting like a little agenda for the live stream. So I've got my little notepad. I've got a brand new notepad on my desk there, and so I can write down notes when stuff pops into my head and think, oh, that'd be interesting to talk about, or whatever, blah blah blah. Anyway, so yeah, so I'm going to touch on this subject now, because it's been in my head this morning anyway, and it's something I think about. Not like every single day, but sort of like on a fairly regular basis sort of thing, because it's a subject I'm fascinated by. Now, I don't pretend to understand a lot of it or whatever, but again, it's like all things I've said before, that I've got little bits of knowledge, you know what I mean? So I'm not like an expert on it or anything like that, but I'm definitely going to study it a little bit more, definitely in my own time. I'm not going to go to college or university or anything like that necessarily, but I definitely, something I want to look into more, and I have studied it a little bit, and I've watched some documentaries on it, and I've watched some videos on YouTube that explain it in layman's terms and stuff. But anyway, let's get to the subject finally. So, quantum physics. Now, there's a big subject. I love quantum physics, absolutely love it. I don't pretend to understand it completely or anything, or even, well, say completely, I barely understand it really, I suppose, but I mean, I grasp it to some degree, but you know, I don't pretend to be any kind of flipping, you know, genius on it or anything like that, far from it, but it nonetheless fascinates the heck out of me. It's an amazing subject, it really is. It's really, really, truly fascinating. And there's this thing, a particular part of quantum physics that I find particularly interesting, but all aspects of it really. But this one at the moment particularly is this thing called quantum entanglement. Now, quantum entanglement, basically, it's really, really fascinating. Basically, you have an atom, and it could be an atom of anything. So take the most basic atom, which is hydrogen. So the most basic atom you can think of, it's the most abundant substance in the universe as well. So you take a hydrogen atom, and now there's a thing where they have, in physics, they have this thing called the measurement problem, where you can't, when you're trying to measure, and in terms of measure, it's like, you know, sort of like the speed that the atom is moving, and there was a, you see, I told you I'm not an expert on this, but there's a couple of aspects where you can't measure its speed and its position both at the same time. You can only measure one or the other, and you know, it's, for whatever reason, you know, you can't. And this also links into Schrodinger's cat, which was a thought experiment by a guy called Schrodinger, who back in like the 20th century, you know, that makes it sound like it was hundreds of years ago. It wasn't that long ago really, but yeah, so like, you know, the beginning of the early part of last century anyway, I think, I can't remember exact years he was around. He's not with us anymore. He's, you know, a lot of these big names now in physics kind of, you don't, you know, they're not around anymore, sadly. But anyway, so Schrodinger come up with this thought experiment in terms of like, because there's a thing called superposition which an atom can be in, and that's another fascinating aspect to this superposition, and this links into quantum computing, which is another thing that they're looking into, and they've even built some very basic quantum computers, and at the moment they're like the old computers back in the day when they were first building computers, like it fills almost the size of a room, do you know what I mean, these quantum computer things, because obviously they're early infancy of creating these things called quantum computers. But anyway, the thing is that basically an atom can be in what they call a superposition, whereby it can be both sort of like flipping it, see, it's like an on and off switch. So I mean, that's maybe not the best analogy in the world. I'll try to remember some of the stuff I've picked up and learnt about this. But basically, the atom can be in two places at the same time, essentially. It sounds impossible, but that's the thing. You see, classical physics, the physics of the world, the macro world around us, solid objects and all the rest of it sort of thing, quantum physics defies all the classical laws of physics when you get down to the quantum level, and it's like really, it's counterintuitive. It's like, it's just really crazy. It's a crazy sort of world down at the quantum level, and so an atom can be in both two places at the same time, and like I say, there's this thing called superposition, and they can use that property. They don't know exactly why or what causes it. They still don't know the underlying fundamentals of it, but this quality that atoms have, where they can be in this, like say, this superposition, makes it ideal to use as for quantum computers, because basically it's like your basic computer works on the binary system where it's ones and zeros. So the zero could be the off position and the 1 being the on position, and so it's got a very limited, even with the most sophisticated supercomputers you can think of, Deep Blue and all this lot and all the rest of it sort of thing, that they would, you know, if you could build a quantum computer that could basically it would make like something like Deep Blue or wherever, some of those really amazing super duper, like, the most incredible computers you can think of that are using the binary system today, would make them look like pocket calculators next to a quantum computer. And anyway, so I'm kind of deviating slightly because it's such a fascinating subject and it's such a myriad of different aspects to it. But let's get it back to the quantum entanglement thing, because it's part of that, the superposition thing. Because basically when they're trying to measure, either the speed or the position of the atom, like I said, you can't measure both at the same time. And there's a really fascinating thing about this, and I forget which scientist discovered this, but it's been proven since. But basically, and that's where Schrodinger's cat experiment comes in as well, is that when you measure an atom, you actually change what you change it, so how can I explain? Right, so Schrodinger's cat was, you've got a cat in a box. Now obviously this is a thought experiment, obviously nobody would suggest that you actually do this for real. I'm noticing the wind again, sorry folks. You see, I don't know how much it's hitting the and whether it's blocking out what I'm trying to say to you guys. Maybe I should have picked a better spot. Anyway, so Schrodinger's cat, so you got a cat in a box, and you've got apparatus that detects the release of an atom, and connected to that is a bottle of cyanide, and basically like when the atom is released, it releases the cyanide out of the bottle. Now the thing is that, like, because you don't know, whilst the box is closed, the atom could be either released or not released. Do you know what I mean? You've no way of knowing until you open the box. Sorry, that wind's starting to annoy me. Right, let's move. Sorry, because I have no idea whether that's picking it up or not. Maybe do you know, I said I was going to touch on this subject. Maybe I should just leave this until I get home. Well, not today, but for Monday, I mean. I'm just trying to think where else I could do this right now, where there's no flipping wind. It might have been fine for all I know. It's not. You see, I won't know until I get back home and play this back when I'm editing, whether it's actually had an effect. Whether it sounded like a flipping hurricane or it didn't. Do you know what I mean? It might not have done. It might have been perfectly fine. And it's only a gentle breeze, but that's the thing. Depending on how it hits this camera, even if it's a little gentle breeze, can actually be quite loud. So, it's just really frustrating sometimes, because it's really difficult to know, whether the wind is actually, creating a situation where you guys are struggling to hear what I'm saying. See, I can hardly feel anything now. There's a little bit of breeze, but there's nothing much down this end. But there's nowhere now to put the camera, and it means I've just got to hold it, and I've got to hold my coffee at the same time. It's just rather awkward, because like I said to you just a minute ago, like, the thing with me is when I'm talking, I'm very expressive with my hands. I talk a lot with my hands, and it's funny because at school, one of the nicknames, I had a few nicknames at school, some not very nice, but anyway, but yeah, so it's like, one of the nicknames I had was Magnus Pike, which for a lot of you guys, even here in this country, you probably won't have a clue as to who or what that is. It was a guy called Magnus Pike. He was a scientist, but he was one of those like TV scientist dudes. I better not put it on there. It can be really funny around here about filming and stuff and what have you. See, now I'm coming out here and it's going to be even windier, I bet. Hang on. Sorry folks. Oh my god, my arm is killing me right now. My arm is aching. I can't swap over, obviously, because I've got this coffee in my hand. Wait a minute, give me a second here, folks. Let's see if we can find a less windy spot. Huh? Kind of looking down there thinking maybe, but then again, you see, that's the thing, tall buildings create wind funnel type areas, basically. Right, hang on. I'll just pop that there for a second. Right, so I'm just going to have to do it this way for a minute. So anyway, yeah, so quantum entanglement and Schrodinger's cat. So the cat's in the box, and you don't know whether the atom's been, you know, the atom's released, and so you don't know whether the cat's alive or dead. Now don't forget, like I said, this is just a thought experiment. Nobody would suggest, and nobody ever did suggest, that you do this for real. Do you know what I mean? This is just, it's literally a thought experiment, you know, to try and illustrate this weird property of the, you know, an atom being in what they call a superposition. Do you know what I mean? So, right, hang on. I'll tell you what. Let's go down here, out of the way. Getting some funny looks. So, yeah. Anyway, so. So being in a superposition, like I said, basically means that the atom can be either in the off position or the on position, and until you actually measure it, i.e. look at it and say obviously you won't look at it with your naked eye because you can't see it, but you know, you look at it through the instruments that you use to measure it with, and that's why the Schrodinger's cat thought experiment is used as a way of simplifying, because obviously it's a really difficult. Even Einstein struggled with all this. Do you know what I mean? And flipping heck, let's face it, Einstein was flipping genius, man. Do you know what I mean? So if Einstein was struggling with it, see, I've got a nice convenient. Ooh, no, perhaps not. Or maybe, yeah. There's a convenient little wall here. I'm going to stick you guys there. Well, actually, do you know what? Wait a minute. Oh boy. I'm just trying to find a nice little spot where I can just plonk you guys down for a minute. And at the same time, avoid wind and all the rest of it. Flipping out, I've got to also keep an eye on the time. I'm getting carried away with this because I love this subject. It's fascinating subject. I mean, seriously, it's amazing. Anyway, so Schrodinger's cat, like I said, you can either, you know, you won't know whether the cat's alive or dead. So essentially, the cat will be alive, both alive and dead at the same time. Now I know, again, that sounds really weird. It sounds like, hang on, but how can that be? Do you know what I mean? It's like, doesn't make any sense. Do you know what I mean? And you're absolutely right, it doesn't. And that's the thing about, sorry. Right, hang on, sorry folks. Oh, for flipping heck. Come on. Right, so, yeah, that's the thing about it, you see. That's what makes it so fascinating, is that, like, you know, logic would tell you that, like, that's impossible. The cat can't be alive, both alive and dead at the same time. Do you know what I mean? But until you open the box and observe, you know, the cat will be in one position or the other. So as soon as you open the box, the cat's either alive or the cat's dead. Yeah? And so it's, like I say, so when you observe, it's only when you observe the atom that it then takes one position or the other. Do you know what I mean? So until you observe it, yeah, it's either on or it's off, if you like. Trying to keep this as simple as possible. And it's just really fascinating. I love it. And then linking back to the quantum entanglement thing, you see, the thing is that this superposition thing basically is what happens is that, and again, they've done experiments with it. See, wind's following me around here. Hang on, have I zoomed in here? For crying out loud. No, sorry. Just looks like my face is covering the whole screen where it normally doesn't necessarily. Or at least not every time anyway. Right, hang on, give me a sec. Right. I'll tell you what, let me just walk down here a bit. Oh boy, what am I like? So anyway, yeah, so quantum entanglement, basically what it is that, like, so say like you've got, I'm trying to think of easier sort of ways of explaining this to you. So basically, what happens is that in terms of this superposition, oh, the tables are not out. Normally some tables like this little, what's the name? I thought maybe that'd be a little nice quiet spot, but flipping heck, I'm being frustrated at every turn here. Oh boy. Now it's quite dark in this little bit as well. Waffle. I was thinking of using these steps, but I don't think that's going to work somehow. Oh, never mind. Maybe I should have just stayed where I was there. Never mind. So, in terms of, like I said, the superposition thing. So, you can get an atom, and like I said, they've done experiments in laboratories, and they've actually proven this, and they've actually shown this to be the case, which again is really, really fascinating. Do you know what I mean? And it's like the scientists themselves don't fully understand the principles or why it does this. But anyway, basically, so say like you've got a hydrogen atom, and so you decide to measure its speed, and it's rotating, say, clockwise, say, for instance. So let's just, for argument's sake, it's rotating clockwise, and you know, you've taken the measurement of its speed. Now another atom, and again, they don't understand how or why they actually become entangled the way they do, but the basic premise is that, like, so you've got the atom, the hydrogen atom, and it's spinning in a particular direction, and then there could be another atom, and this is theoretical, but they've done this in the laboratory, so they know it actually happens in the physical sense. You know what I mean? That, like, so let's stick with the laboratory for a minute, but I'll explain in a minute. So basically, what happens is that you've got the hydrogen atom number 1, and it's spinning, say, clockwise, and then atom number 2, which could be way over on another building in the laboratory, whatever, will also then spin in the same direction. Or actually, no, is it the opposite direction? I can't quite. Basically, the two atoms become quantumly entangled. So what happens with one atom will also happen with another atom, and they reckon that is also can happen sort of in one galaxy. So you can have a hydrogen atom here in the Milky Way galaxy, and you observe it and what have you, and there's another atom in whatever other galaxy out there, billions of light years away, and it too will respond, and they still don't fully understand how this works. You know what I mean? They're obviously working on the issue as we speak, but I mean, flipping it, think about that, folks. I mean, like I said, I must admit, maybe my explanation isn't the most clearest, to be quite honest, because like I said, I only barely flipping grasp what they're trying to say. Do you know what I mean? And even they do. Do you know what I mean? Even the experts only barely grasp it. But still, it's really fascinating. You think about it. You know, you think about there's an atom somewhere. You know, could be anywhere. Do you know what I mean? Floating around, there could be an atom in front of me right now that could possibly be quantumly entangled with another atom billions of light years away. Do you know what I mean? And that's just mind-blowing. Do you know what I mean? It's absolutely mind-blowing. And you see, this is why I love it. I love it. It just fires my imagination. It makes me think of all sorts of possibilities. I mean, I just wonder, and again, this is why I go back to this thing about, you know, whether there's such a thing as ghosts and this, that, and the other, and blah, blah, blah. Because the thing is that it makes me wonder, it makes me think, could it, you know, the phenomena of either UFOs, ghosts, or anything like that, anything paranormal, could that be linked to this, the quantum stuff, like I said, about energy, certain energies and energy fields and stuff, and then how people respond to that? I mean, they know, for instance, that, like, magnetic fields, if you're in a very strong magnetic field, they can induce hallucinations, it can induce auditory and visual hallucinations and stuff like that, and again, this has been shown in laboratory experiments and so forth and whatever sort of thing. So, you know, the thing is that I wonder if that stuff, all of that stuff is connected, and it wouldn't surprise me that it is, you know what I mean? So you see, this is where my little theory is coming from about whether, you know, the paranormal and stuff is something that we're interacting with, and it's a real phenomenon, I reckon, because there's way too much documentation to suggest that it's all just make-believe and it's all made up or whatever. Do you know what I mean? There's way too much documented evidence in terms of film footage and other stuff as well. But like I say, whether it's the spirits of dead people or not is another discussion in itself. But yeah, it's I just like I say, I just love quantum physics. So I think if people want to, you don't have to necessarily, but it's a subject that I find absolutely, totally fascinating. But at some point, I think I'd like to do that on the live stream. We've got 2 hours, so we can discuss that for 10 minutes, 20 minutes, whatever, and then discuss whatever else after that. But I think that's definitely going to be down on the agenda for Monday, because I want to get your guys a bit of input on it as well. And you know, don't get me wrong, I understand that, like, you know, maybe a lot of you won't have a clue what I'm talking about necessarily, because you might not be into it or whatever. But you know, nonetheless, just give me your thoughts anyway, do you know what I mean? Because it is a fascinating subject. And like I say, I don't pretend to understand it necessarily. I just find it really fascinating and interesting. Right, so okay, I'm going to leave it there for now, folks, because obviously I need to get back into work. Well, get into work. And I have no idea what the time is right now, actually. I better just keep... Because I'm getting so caught up in this that I can't... Hang on. Oh yeah, 10 to 8, right, gotta go, folks, so I'm gonna catch you guys later. Bye for now. Okay folks, so the marathon vlogs start here. The vlogathon, it's Friday obviously, it's the weekend, and I'm assuming that there's going to be a vlogathon. I mean, I've already started this morning, but now it's break time, so... Well, I say break time, what I mean is, obviously, I've finished my shift. So, obviously, I'm going to have my Swedish meatballs. So, do you guys want some? Let's take a bite. That was a massive bite you guys took there. Whoa, flipping heck. You were hungry. Wow. Catch you guys later. Bye for now. Yeah, so I'm thinking... because I was originally thinking I was going to go and mooch around, but do you know, that's the thing, like I said, you know, it's amazing how tired I can get. Do you know what I mean? I'm absolutely, my back's hurting me. I am so flipping tired right now, you know. Try and get across this road, guys. Yeah, probably going to be in shadow here on this side because the sun's not on this side of the road. But the number 3 bus stop is, so that's basically what I'm going to be doing in a minute. I'm going to jump on this number 3. Oh yeah, so I'm just absolutely super tired, guys. Again, try to avoid this wind as much as possible. Although at the moment it's not that easy, not that simple. Oh flipping heck, I can't. Sorry, my back is killing me right now, guys. Boy. Yeah, so like I said, I'm not gonna go mooching as I originally sort of planned. I thought, like, yeah, after work, stay in central London rather than traipse all the way back home or whatever, blah blah blah. But I just gotta get home and get some sleep, because also, like I say, tomorrow definitely, I think, yeah, I'm almost 90% certain I'm going to go to Wembley, because like I said, I've not been down there for a little while, and Sandra has kind of asked me to go and film her hold haunts around there, and I'm sure it'd be an interesting and fascinating place and area to film anyway, and I don't think I've done that many vlogs, if any, down there, to be quite honest. So I'm thinking, why not? You know what I mean? Be somewhere different, somewhere we've never been, and who knows? We may stumble across an abandoned building somewhere, maybe, because I've never really explored that part of the world much before, or that part of London, if you like. So yeah, it might be worth a little trip down there tomorrow. I don't think it'll cost that much to get down there, I don't think, and it's pretty straightforward, I would imagine. It's not that convoluted. Probably a couple of tube trains, I imagine. So I can't see it being that much necessarily. Yeah, so anyway, like I said, I think I'm going to leave it there for now, because I am super tired, and these vlogs are probably, like I say, for some reason I just can't stop vlogging at the moment, you know what I mean? It's just vlog. But like I say, I'm enjoying it. I'm really enjoying it. Right, I'm not sure if I can see I think my bus is coming up. Right, so I'm going to leave it there for now, folks, and I'll catch you guys later. Bye for now.